becoming any window that shows me anybody on the conference. So I have no way of knowing whether I'm actually in or not. So
I see. But I guess the previous invited talk run a little bit over time. That's why Yinglong, the session chair, is not here yet.
okay.
So let's wait for like 30 seconds to 1 minute. And if not, I'm going to step in and introduce you, kick off.
Okay.
Thank you.
Yeah, thank you.
Yeah.
I hope my machine doesn't choose to reboot. Please don't.
Hello, everyone, and we'll start the second event talk in our second half of the workshop. We'll welcome Professor Rama from IBM. I'll have a quick intro of Rama. Rama is an IBM fellow, master inventor, and IBM Academy member at IBM's automation division. Well, she is the CTO of AI operations, and Rama has been named by Forbes as one of the top 20 women in AI research. She has been featured in 18 in AI by Fortune magazine in 2018 and named as top 10 pioneering women in AI and machine learning by Enterprise Management 360 in 2019. Rama is also recipient of the University of California, Berkeley's Eisen Award of Technical and Executive Leadership for 2020. In Rama's career, she has worked on agent-based decision support systems, business process management, electronic marketplaces, and semantic web services. She led a worldwide web standard, and Rama co-authored 4 book chapters on over 100 technical papers, and so many awards. And I will just finish here. And it's great to have Rama here. Rama, we'll talk about AIOps today. Rama, please.
Hi. Can you hear me okay?
Yeah.
Okay. Yingnang, thank you for that introduction. Appreciate it. And Jiang, thank you for inviting me to speak at this conference. Welcome, everybody. Good afternoon, good morning, good evening, wherever you are. It's good morning for me here in California. I wanted to talk about the work that we are doing at IBM on AI operations. If you're wondering what that is, it's really about applying AI to automate and optimize IT operations management. We had the vision long time ago for self-healing, self-managing, and self-monitoring IT applications. But that vision was somewhat unfulfilled up until now for various reasons, some being the technology was not there to realize that vision and the compute wasn't there and so on. Now, with really the confluence of various factors, including the availability of the compute, advancement in machine learning algorithms, and natural language processing, we are now able to really get to that point of realizing that vision of self-aware, self-healing, self-managing IT systems. And AI operations is a name that's coined by Gartner to capture this area where AI can be applied to automate and optimize IT operations management. So I'll talk about that today. Just to kind of level set and also introduce what problem we are solving, let me present the following scenario. In pretty much every company organization, there is a lot of IT. There are systems, business applications running on infrastructure, which could be cloud native, or it could be virtualized, it could be traditional software applications running on traditional servers. Underneath them, there are networks, routers, and everything supporting it. So if you look at the full stack of business applications that are supporting mission critical business processes and those sort of things, all the way, they're running on the full stack from software to hardware to networking devices, routers, and everything. And any number of things could go wrong in an application, in an IT environment. CIOs are worried about making sure that their applications and systems are up and running, are available, they're resilient, and all that, even while advancing the modernization agenda that they have to bring many of their applications to more modern platforms and such, and also to drive innovation in their business processes. So that's a tug and pull. As you introduce more innovation, there tends to be a instability because it's new applications, new systems that you're introducing, and it takes them a while to get settled down. And during that process, systems could go down and such. And negotiating the complexity and scale could be an issue, especially when, as part of modernization, many companies are moving toward more microservices-based architectures. So they're ending up with many smaller modular services, which is good from an architectural point of view, but from a maintenance point of view, there are more points of failure. And if you look at it from IT operators or operations admins point of view, they are having to deal with many applications. They're overwhelmed by not only the number of applications that they have to manage and the number of services, but also the number of tools that are at their disposal to manage them. So, for example, the logs that are written by applications, the metrics that they produce, the ticket systems in which the various incidents are being managed, and customer and internal incidents are being managed and such, and the tracing, the deployment configurations, and there are so many different artifacts, and for each artifact there is a special purpose tool or something that is at their disposal, which is a great thing, but they have to use so many tools to get their job done, and all these tools often are not connected, and as a result they're getting burnt out, and constantly are these IT operators, sometimes also referred to as site reliability engineers or SREs, find themselves in this catch-up cycle where they're constantly in reactive mode. They are trying to fix a problem that has occurred, never have enough time to actually go and actually avoid the incident from happening in the first place so that they don't have to be in the reactive mode. So that is the problem. Just also, let's look at the day in the life of a person called Carlos, who's an IT operations engineer. How would that person deal with this in their day-to-day life, managing the events that occur? They may have the best of the breed tools, could be metric monitoring tools like sysdig, could be PagerDuty alerts being set up, LogDNA type of log management tools, or Splunk, or Humio, or Elk Stack, ticketing management tools like Jira or ServiceNow, and all kinds of things at their disposal. And yet, when a problem occurs, it starts with a PagerDuty alert that they get. Then they go into look at the metrics being displayed by the business applications that they're responsible for monitoring. Then they look at the logs written by these business applications. Then they go into chat mode, whether on Microsoft Teams, Slack, conversing with their colleagues to see what is this problem about, if they have seen it before, and what to do about it. And they're constantly going back and forth between these tools, trying to diagnose what could be the problem. And hours go by the time they diagnose it. Then what, after diagnosis, they have to figure out what to do to fix it, what kind of remedial action to take, right? So all of these, I'm showing the hop, skip, and jump between many tools that happens today. And, could be 5 hours and could be sometimes several days would pass by before you diagnose the problem and actually apply the fix. Sometimes up to 17 steps, 20 steps, sometimes takes up to 10 to 15 people, and people get in war rooms, and different divisions are trying to point fingers at each other, saying, AI, it's not my problem, it's network problem, it's device problem, it's infrastructure problem, it's that particular service went down, it's a pod problem, whatever the case may be, and fingers are getting pointed, and there is a lot of emotion. What we want to be able to do with AIOps are bringing AI to really bring a holistic problem context to this whole process of identifying, diagnosing, detecting the problems that occur, and actually get to a point where you can prevent these problems from happening in the first place. That is our vision for AI ops management. And in the process, the metrics that we are trying to optimize are mean time to detect, that is MTTD as it is called, mean time to detect, or mean time to isolate and diagnose the problems, mean time to fix these problems as quickly as possible, mean time to verify that they're fixed. And some statistics go actually several billions of dollars of costs are attributed to loss, that is revenue loss, or costs or customer dissatisfaction is attributed on an yearly basis to IT outages that occur. Every day you hear, either there was a security threat or an IT outage because of which, airline reservation system was down, or a retail shopping cart checking system is down, or, a particular social media platform is down, banking operations are down, and, you hear them. If only we could get to a point of that self-healing, self-monitoring, self-managing IT systems, we would be able to reduce these mean times to detect, isolate, diagnose problems, and to get to a point where these problems don't happen as often, if not never. So our vision for AI ops is to go from being reactive to predictive to proactive. And in the process, AI may start being an augmentation to human abilities, where people lead the processes, where AI is augmenting their capabilities, to slowly leading, and where applicable, getting to a point of full automation, and freeing up people's time for doing more high skilled types of tasks. So, carrying on that vision, if we look at the software development lifecycle, all these IT applications, I'm talking more on the business process, business application level. Of course, at infrastructure level, this doesn't quite apply. If you're specifically concerned about managing IT systems from infrastructure on down, the software development lifecycle doesn't quite apply. Not as much, although these days with software defined environments, even that is there. But if you look at it, we design software systems, we code, build, test, deploy, and run. Majority of the metrics or the types of data that are being monitored today include things related to concerned with the run or monitor stage. They include application logs, system logs, metrics, tickets, as we spoke about. But if we want to avoid those incidents from happening, we need to be able to really look at the software development lifecycle process and institute checks and gates to ensure high quality of those processes, so that poor quality artifacts don't get promoted to the next step. And as a result, as you improve the quality of these processes, the overall maintainability of the application stabilizes, and it increases and improves. And that's the idea. And in the industry, this is called shift left. I like to think of it more as really instituting these feed forward and feedback loops, wherein anything that any bad things that have happened, the prediction, any kind of issues that happen in production, the data can be used to learn models to give that feedback during deployment stage, testing stage, coding stage, so that you can predict if a particular artifact is of good quality or not. So for example, in design stage, we are talking about design specifications, design documents, and FR documents, and those types of things. At coding stage, it's the code, the libraries, the topology, the static topology, that is the code images, those sort of things. At test, it's the test cases, test coverage, and those things. In deployment, it's the deployment configuration, deployment lineage, And at run, it's the logs, metrics, topology, tickets, alerts, events, and all of that. So if we learned models from the prior incidents and use that to predict if you're going to deploy a change, that will tell you whether it's highly risky one or not, and use that as a guideline to avoid incidents from happening. Don't promote high risk deployments. Fix whatever the problem is before you promote it. Similarly, test. Don't promote highly untested software, or don't. If a code has security vulnerability, detect it early based on the prior incidents and suggest where the problem is, and uh, have the software engineer who is building the code actually fix it before they promote it to the next stage. So that is our vision, and this chart is showing the progression of it as really the checks and gates, like the planning, coding, building, testing, releasing, deploying, monitoring, optimizing, as as the software development lifecycle stages. And when incidents do happen in production, use that data and the root cause that was associated with it to learn models, machine learning models, to be able to predict for the next iteration of deployment changes or release changes or test changes, build and coding changes, and institute those gates being risk predictions, basically, that tell you how risky it is, that particular artifact, what might be the vulnerabilities in it, what to do to fix it, and what is the business impact associated with promoting that artifact to the next stage if you choose to ignore the warning and still go ahead and promote that artifact to the next stage. So that's our vision for proactive issue avoidance. So what are we doing? What AI are we applying? Let me talk about that in the next few minutes. If we have the opportunity to look at logs and predict anomalies from them, we have the opportunity to look at metrics, predict anomalies from them. All of those anomalous events can then be brought into an event grouping algorithm pipeline, wherein you first of all filter out all the kinds of events that don't need to be brought to an SRE's attention, because some may be self-resolving incidents, some may be low priority ones. So you look at all of those things based on preferences and policies, filter out, but then there might still be sometimes hundreds of events getting generated or alerts getting generated related to the same incident. So you want to group them so that the SRE doesn't get inundated with hundreds and thousands of messages, either on the pager duty, on their phone, or on Slack messages, or Teams messages, or chat messages. So the idea is then to group those events. Then you want to localize the fault. Okay, so this is you're telling me that all of these events are related to the same incident. What happened? Where is the problem occurring? Is the problem in the particular service? Is it the pod? Is it the node? Is it the service infrastructure? Whatnot. So that's the diagnosis and fault localization. And finally, once you diagnose, you want to be able to really suggest where the problem, how to fix the problem, and predict risks associated with it. So for each one of these things,
1 minute.
yeah, for each one of these things, we have built AI pipelines and machine learning models and prediction algorithms. So here I will show you this one quick screenshot. Oh, sorry. So the way we do it is to deliver this information in reactive mode in Slack, right, where or in Microsoft Teams, where the problem occurs, quickly show it to people that an incident has occurred, give them an alert, show them with explanations. Machine learning models with explainability are chosen for that, and with on the topology, visually show where the problem is, and be able to understand why these events are grouped to one another, and finally be able to search for a resolution where we apply natural language processing to on prior ticket data to find to retrieve specific actions that were taken last time such an incident occurred, which might be the action that you may want to take now to resolve it. And this is done through natural language processing. And finally, if there are run books or playbooks associated with it, that action, automatically run it and execute it. That's in the reactive mode. In the proactive mode, we have built models to predict the risks associated with